Few plants can regrow hair. Even fewer can halt liver fibrosis. Platycladus orientalis does both, and the science explains why. Platycladus orientalis, the oriental arbor vitae, contains a chemistry profile powerful enough to influence two systems that almost never overlap: the hair follicle and the liver. And the reason is found in the bioactive compounds concentrated in its leaves. Let's start with the hair. Inside the leaves is a compound called cedrol, a sesquiterpene alcohol that fundamentally changes how the follicle receives oxygen, nutrients, and circulation. Cedrol increases perifollicular blood flow, pushing more oxygen and growth factors directly to the root. It enlarges the dermal papilla, the command center of the follicle, and it extends the anagen phase, meaning the follicle stays in active growth longer and produces thicker, stronger hair. In controlled studies, cedrol didn't just compete with 2% minoxidil, it exceeded it in several parameters: faster anagen induction, greater follicle size, and denser regrowth over the test period. But cedrol isn't acting alone. The leaves contain powerful biflavonoids, especially amentoflavone, hinokiflavone, and cyadopiticin. These compounds neutralize oxidative stress inside the follicular environment, reduce the microinflammation that chokes the follicles in early-stage thinning, and protect the collagen structure that anchors each hair strand. They also shield follicles from UV-induced degradation, a major but overlooked cause of chronic thinning. Together, cedrol and the biflavonoids create a multi-pathway effect: greater blood flow, stronger follicle signaling, deeper antioxidant protection, and a more stable growth phase. The result is a follicle that stays alive, stays active, and stays growing. But the chemistry that protects a hair follicle also protects something far more vulnerable: the human liver. Inside the same leaves are labdane-type diterpenes, the most important being pinaceline and lambertianic acid. These compounds target one of the core drivers of liver damage: hepatic stellate cell activation. When stellate cells activate, they lay down collagen. When collagen builds up, fibrosis begins. And when fibrosis progresses unchecked, the liver hardens, stiffens, and loses its ability to regenerate. Pinaceline acts as a platelet-activating factor antagonist, shutting down inflammatory cascades that drive fibrosis. Lambertianic acid goes even deeper. It directly interferes with the signaling that tells stellate cells to produce scar tissue. In laboratory models, extracts of Platycladus orientalis reduce collagen deposition, improve liver enzyme profiles, restore antioxidant capacity, and protect hepatocytes from oxidative injury. Glutathione, superoxide dismutase, and catalase, three of the liver's primary defense enzymes, all increase under its influence. And bridging both systems, the hair and the liver, is a broad suite of flavonoids like myricetin, quercitrin, and aphyllin, plus water-soluble polysaccharides that regulate immune activity and reduce inflammatory load throughout the body. Hair grows when inflammation falls, circulation rises, and oxidative stress is neutralized. The liver heals when fibrosis is interrupted, stellate cells quiet down, and antioxidant defenses rise. Platycladus orientalis delivers all of these effects from a single biochemical profile. Cedrol activates the follicle. Biflavonoids protect it. Diterpenes defend the liver. Polysaccharides stabilize the immune response. Different tissues. Different pathways. One plant capable of supporting both.